360, 370 instruction. It is divided into two categories. One of them is pseudo instruction, okay, pseudo opcode values, and another one is the machine opcode value. Okay, when we are talking about machine, the location counter of the machine opcode is always important for solving IBM 360, 370 pass 1, pass 2 assembler. Okay, and what about pseudo opcode instruction? So you can see list is given, start assembler directive. Okay, it is nothing but your assembler directive. End DC declare constant, DS declare storage. Using, okay, using is also a kind of pseudo opcode instruction. Okay, and this using, it always comes with the combination of the register number. Okay, so when you will see some kind of assembly language program related to IBM 360, 370, there you can see using star comma 15. Okay, so it will be like this, using star. Okay, and many of time this base register is used. This is known as the base register 15. Okay, this is the value of the base register. And what about this star? Star is the location counter value, current location counter value. And what about this 15? 15 is the register. So you can see one modification if we compare with the previous pass 1, pass 2 example and this pass 1, pass 2 example, this using may appear there. And there is a list of instructions are given in the Donovan book. Okay, I will just send you that book. Just go through each and every instruction. Here we'll be considering some of the instruction from that Donovan. Okay, so this is related to using. Then you already know about this LTORG. When literal is encounter, we need to address or we need to provide the addresses to the literals and equate EQU. So all these are the pseudo opcode instruction. So here, while solving pass 1 and pass 2, we need to generate one more table that is known as POT. Okay, POT table means what? Pseudo opcode table. Okay, and another one is what? Machine opcode table. So two more tables have been added, or two more data structure have been added when we are solving example for pass 1 and pass 2. Okay, so there are machine instruction related to register. Okay, it might be register index, it might be storage immediate, might be storage, register storage, or storage. Okay, so these are the machine instruction you can encounter in assembly language programming. Okay, so that is the another category. So don't get confused. I'll be having a simple example so that your idea will get clear. Okay, and one more is there for machine instruction, that is drop. So you can see this list is whatever example we need to solve. I'm summarizing only those instructions. You may find out more instruction in reference book. Now, what are the types of register? Once again, we will discuss. If we are working with RR, register type of instruction, so we need to increment. Okay, we need to increment the location counter value by 2, right? If it is RR type of instruction. If it is your RX type of instruction, then we need to increment the location counter value by 4. Okay, why? Because it is the 4 byte. Then RS instruction means what? Register storage. Again, we need to increment by 4 byte. If it is SI instruction, 4 byte. If it is SS instruction, increment the location counter by 6 byte. So this is the count you need to remember while solving the IBM 360, 370 example. Okay, so here I have given, you need to refer page number 33 from the Donovan book. So there you will get the list of each and every instruction given there. So there you can find out the group. Okay, there you can find out the group. Some are eliminated, or the last character of instruction is R. If the last character instruction is R, then this is the register type of instruction. If it is I, then it is storage immediate type of register. Okay, likewise. So here we will discuss. If instruction ends with R, then it is register type of instruction. And when it is register, increment the location counter value by 2 bytes. Okay, so some of the examples are given in the groups. Okay, we can perform addition, we can perform division, multiplication, subtract, comparison, branch and link. Okay, Boolean values, we can add Boolean values also. So all these operations, they are having some kind of group. Okay, so you can find out if this D means what? Divide, R, divide register, so it ends with R. Okay, so this is the RR type of instruction. So in that case, if this is the statement in your assembly program, you need to increment the location counter by 2 bytes. Okay, if AR is there, again 2 bytes, SR is there, 2 bytes, compare is there, 2 bytes. And this is also important instruction, that is BALR. BALR means what? Branch and link. Okay, branch and link. So this is the category of register. Second category of the instruction is SI. If any instruction ends with I, then it is your storage immediate kind of instruction. Okay, so you can find out the list here. So I am writing some few instruction: CLI, compare, logical, compare. Okay, all these are the instruction ending with the I. So in this case, you need to increment the location counter value by 4 bytes. Okay, next category is what? RX type of instruction. So those instructions, they are not ending with I or R. Okay, then it is known as RX type of instruction. Okay, are you getting me? It is known as RX type of instruction. So in that case, you can have to increment the location counter value by 4 bytes. Okay, am I clear about this? Yes, any doubt? You need to remember this. Okay, I will provide you this PDF while solving the example. Now next category is what? What is the format? What is the format of instruction? So instruction format can be given with the data. Okay, data means any kind of label. This is the direct example. Data, it is known as label. Then what is this? This is the this is whether it is machine or pseudo instruction. Tell me. We have just discussed. This DC is machine instruction or pseudo instruction?
Pseudo instruction.
Sudo.
Very good. Okay, this is the pseudo instruction. So in our example, we will be having the table for this DC, separate table for this DC, and there we are storing the location counter value. Okay, in short, address. What about this? This is our operand, F dash S dash. This is the operand. Okay, what this F indicates? This F indicates the full word. Okay, so in any assembly instruction, you may encounter H before any constant, or F before any constant, or D or C. So if this is the case, you can encounter in assembly language program, then again you have to think about this bytes. If it is half word, then it is 2 bytes. If it is full word, then it is 4 bytes. If it is double, then it is 8 byte. And if it is character, only 1 byte. So when we need to encounter or when we need to recall all this definition, when LTORG instruction is encountered in our assembly language program. So there we are setting the addresses to each and every literal, right? So this constant value will be assigned the address related to number of bytes. If we are encountering full word, so here you can see this full word is encountered with this some constant value S. Okay, in double quotes. Okay, it is not dash, actually it is in single quote. Then in that case, you need to increment the location counter value by 4 byte. If you encounter C before any constant value, okay, before any literal value, then you need to encounter your location counter by 1 byte. Okay, so this is the general instruction format. So without wasting our time, what are the steps? So steps are, first of all, we need to assign the value of the location counter similar to our previous example. Then prepare how many tables? 4 tables are required. So how you will differentiate between IBM instruction and other example? So in the problem statement, you may find design or solve the pass 1 and pass 2 phase of assembler by creating symbol table, literal table, base table, machine opcode table, or POT, pseudo opcode table. Okay, if you find out this table, then immediately you should know we need to solve the instruction or we need to solve the example related to IBM 360 and 370. Okay, and if only literal table, pool table, and symbol table values or tables are given there in your problem statement, then it is our previous example. Okay, in this way we need to differentiate. So this is the design procedure for assembly language for IBM 360. So how to assign the location counter value? So what we need to do, we need to write the machine instruction. Okay, like this. Okay, this is our problem statement. Look at here. Okay, I need to remove this. As apply pass and pass 1 and pass 2. Okay, you may find out like this, or pass 1, because here we are solving in one attempt. That's why. Apply pass 1 and pass 2 of two pass assembler to the following assembly language code and generate symbol table, literal table, base table, pseudo table of two pass assembler. Okay, you can find out the instructions are totally different, right? Some is ending with R, nothing is there, R, not X. Okay, then immediately after looking at this problem statement and example, you should know which category is this, whether it is RX instruction, whether it is RR instruction, whether it is SS or SI. Okay, accordingly you have to put the values for the location counter. So here we have created two column of location counter. One is for machine. Okay, so here I am writing M for machine, and another one is for pseudo instruction. Okay, the category that we have seen. One category we have written for pseudo and one category for machine. Okay, so two location counter values are there. This category you can't find out while when you are solving it manually, but for easy incrementation and decrementation of the location counter value, you must add this column, okay, for your better understanding. So that is our pass 1 phase. Need to assign the location counter value and adding addresses to symbol table, literal table. Okay, and again here we can find out the base table value and POT. Okay, we will see while solving. I'm just giving you the rough idea. And what is the output of pass to assembler? So output of pass to assembler, we have to write here the whatever instruction encountered. Okay, and here we are writing the numerical value. Okay, now that numerical value, it is associated with the registers. Okay, it is associated with the register. I have told you earlier, this using it may comes with the register number value. Okay, so this operand 2 is what? That is our register number value. And basically when we are solving this operations, we are assigning some address and some values to the register, respective register. Okay, so this two phases, that is pass 1 phase and pass 2 phase, we will see while solving this example. Okay, now so we will be talking about this. Write a machine instruction and then increment the location counter corresponding to the type of instruction. Okay, whether it is RR, whether it is RX, SI, whatever. Now what is the second step? If you encounter DS and DC, DS and DC are pseudo instruction. Okay, then in that case you should align the location counter. Now what is meant by the alignment? What is meant by the alignment? So let's go for this example. Declare constant. F stands for what? F stands for which word?
Full word.
Full word, right? So F is our full word. 4 is what? Our constant. Okay, say for example, we are having the register number or we are having the location counter as 16. Okay, so we need to add 4 byte to that 16 location counter. Okay, why? Because F is the 4 byte. So for the next instruction, the location counter value is 16 plus 4, that is 20. Okay, if DS and DC are encountered, then we have to stick to the word that we are using, whether it is half, whether it is double, whether it is full. Okay, now another thing is what is meant by alignment. So this is known as alignment. So when we are talking about the alignment for declare constant and declare storage instruction, then it should be multiple of 4 if full word is there. It should be multiple of 2 if half word is there, and it should be multiple of 8 if double word is there. This is very important because whatever we are writing here, whatever we are writing in this machine instruction column, that is our location counter, important location counter, because this value will be putting in addresses, literal, symbol, pseudo, base table. Okay, and based on that we'll be generating the pass to phase. Okay, so directly here we are referring the addresses. So you should think about this statement. If DSDC encounter and if it is a full word, then that address should be multiple of 4. So how we can analyze this? Address should be multiple of 4. See, here 16 location counter is there. Okay, 16 location counter is there. But what happened while incrementing all the location counter by 1? If I encountered here, my location counter value for this is 15, or I will take, okay, this is my location counter value. Okay, so how I can increment 15 plus 4? It is not allowed here. So what machine means, how machine is programmed for this kind of operation, it will search for the multiple of 4. Okay, so which is the nearest multiple of 4? That is 16. That's why it will consider it as 16 and then it will add 4 bytes in it. Okay, if I encounter the one value, okay, for this case or half words case, if I encountered value as I'll take 7. Okay, 7 is my location counter value, but I want multiple of 2. Okay, so you take the net. Yes, any problem? So you can take the next value. So you can go for 8, right? Multiple of, which is the nearest value, next value is 8. So we need to add 8 plus 2, that is 10. 10 is our location counter for first line and it will be given to the next, or it will be assigned to the next instruction. Okay, we will see while solving the example. So that is the alignment. Okay, whatever I have told you up till now, that is the alignment of the address. Now, another thing is what you already know now. If LTORG is encountered, we need to assign the addresses to the literals. Okay, so we have to create the literal table. If symbol is encountered, we have to write the symbol name and their particular location counter value. What is this extra column? What is this extra column? This is known as relative address or absolute address. Okay, so 2 categories every time you have to mention. Now, once again compare with the previous pass 1, pass 2 example. In previous pass 1, pass 2 example, what we have seen, only symbol name, their index and address was there, right, in the previous example. But here, one more extra column has been added. That is, the type of instruction or type of symbol associated with the instruction is relative or it is absolute. Okay, what is meant by relative? If all symbols are having location counter value. See, if we are adding addresses to the location counter value in this column, then that is your relative address. SR instruction, L, A, ST, A, okay, all these are the relative. So you have to put R in this column. And what about the absolute address? When you encounter EQU, okay, when you encounter start, right, when you encounter LTORG, all these are the relative, or sorry, absolute instruction. Okay, means all machine instruction are absolute. If you encounter LTORG and you'll require the address, then in that machine opcode table, here you can write A. Otherwise, you can write R. So many of times you can see while solving this example, you will find out R in that particular column because we are generating the code for machine instructions only. Okay, so same for literal table also. Now, this one extra table has been added in our example, right? You know about symbol and literal table, but what is this new table? Okay, what is this new table? So simply, this is very simple. When you encounter using statement in your example, okay, when you encounter using statement in your example, then you have to add register number and their content. Okay, register number and their content means what? Register number is what? Register number in this case, in the same example that we have seen, here it is 50. And what about the content? Content is nothing but the address. Any address is given here? Yes, address is given here. That is begin plus 2, 0 plus 2, that is 2. So you can write 2. If only blank instruction is given here, like this, in this example, using star 15. Okay, so no value has been added for operand 1. Only star is there, right? So we don't know the location counter. So in that case, here you can write 0. Okay, here you can write 0 like this. 15, 0. Contents are 0. Okay, so here I have given the space explanation. For base table, C using instruction in program. Okay, this is what star indicates location counter value, and this is the register number value. So you can find out 15 register value for each and every example. Okay, so that's all about the thing that we have to discuss now. Okay, am I clear?